When you see an equation with two unknowns, you must be careful. It's very easy to make mistakes. Let's look at this problem. It says, given that x plus y minus 2 times the square root of x minus 1 minus 2 times the square root of y minus 5 minus 4 equals 0. Find the value of x plus y. Everyone, this is a single equation. How can a single equation have two unknowns? That doesn't make sense. Let's suppose x equals 0. If we substitute x equals 0, we can solve for a value of y. Now, if we suppose x equals 1, substitute it in, and again, we can solve for a value of y, right? This goes on endlessly. Doesn't this problem have infinitely many solutions? Could it be that the teacher made a mistake in the question? But is it possible that the teacher didn't make a mistake? There's another possibility. Maybe this equation is of a certain form. You must have this kind of thinking. That is, the square of some expression plus the square of another expression equals 0. When you see this kind of form, don't both of these have to be 0? Right? If it's not in this form, then there's a mistake in the problem, and you could report the teacher who wrote it. So let's try to complete the square and see if we can turn it into the sum of two squares. Look, here's x, and here's 2 times the square root of x minus 1. Let's try to complete the square with these two terms, x minus 2 times the square root of x minus 1. Let's complete the square. How do we do that? Everyone, since there's a square root of x minus 1 here, don't we also need an x minus 1 to appear? The square root of x minus 1 squared minus 2 times the square root of x minus 1, and then you have to add 1 to complete the square. Right? Be careful when you submit your answer. It's the square of x minus 1. Here, this subtracts 1 and this adds 1, so it balances out, right? This expression is exactly equal to that, no problem. Now let's complete the square for y and this part as well. For y, it becomes the square of the square root of y minus 5, right? Right? Then what you need to do next is subtract or minus 2 times the square root of y and then minus 5. And then add 1. The squared term in parentheses. All right, is there any problem with that? So here we have this. There's a minus 5, and here there's a plus 1 minus 4, which cancels out exactly with this negative 4. This is pretty clear. In other words, you should go back and carefully check this calculation yourself. It's just equal to this plus that as the main part. Right? So isn't this just the square root of x minus 1? The square of something minus 1. Isn't this expression just something minus 1 squared? And what about this expression? Isn't it the square root of y minus 5? Minus 1 squared. Check the main part carefully, right? Go through the conditions and verify if there are any issues. So these two squares add up to 0. If the sum is 0, then each must be 0. If this is 0, what does x have to be? X must be 2, right? That is, if it equals 1, doesn't that mean x must be 2? Right? So if it equals 0, then it equals 2. This whole chunk must equal 2. No, it must equal 1. This whole chunk must equal 1. So y must be 6, right? Y must be 6. Wait, why am I getting confused? Don't the two added together equal 8? If you don't believe it, try plugging in 2 and 6. Try plugging them back in and see if it works. Verify it. The board is a bit messy, so you'll need to work through the calculations carefully on your own later, everyone.